given information, you have x equals 0. If we get a quick graph here, x equals 0 is the vertical line or the x-axis. The y equals x square, square root x is the square root graph. Y equals 2, 1, 2 is the horizontal line, y equals 2. And we're going to rotate about the line x equals 4. When you put them all together, let me do it real quick here. The square root, and this one is y equals square root x, and the vertical line, and the line y equals 2. So this is 0, this is 2. And you can see the region bounded by these two graphs. Okay. Once you identify the region bounded by these two graphs, next you see where is the axis of revolution. This problem indicates the line x equals 4 as the axis of revolution. If x equals 4, you plug it in y equals square root x. The order pair here is going to be 4, 2. It's right at the intersection point of the line y equals 2 and the curve y equals square root x. Rewrite this. So write this one as, this one is square root x. And this is the line y equals 2. And this one is the line x equals 0. Now, the axis of revolution at 4. So this is x equals 4. And we name it, we call it the axis of revolution. So the graph, when we do the rotation or revolution, we go about the axis of revolution. And to form the cross section will be perpendicular to the axis of revolution. Okay. No, wrong way, sorry. I'm wrong. So this is the axis of revolution. So perpendicular gonna be crossway like this. Okay. Now, when you see the bar, which is perpendicular to the axis of revolution, and the bar at the end here, that is the y position. Okay, I'm going to name it as a y at this position. One thing you can pull out, since the bar gonna move up and down within the region, that means the lowest y that could happen gonna be 0. The highest y value for this situation is gonna be 2. So we make a list what we know so far, the interval of integration is y from 0 to y2. Okay, and the following part of this, we can say that the thickness of the bar, which is the width of the bar, is the change in y or delta y, and delta y means dy. Okay, we have two things. And then the next part, we're gonna find the radius. If you form the revolution, it's rotating about the x equals 4. Let me move the pieces here out of the way. So this is x equals 4 or the axis of revolution. When you rotate this way, the area will go, let me, gonna form the solid of revolution, something like that. Okay. And the one in blue that you see, it just go around the shape here as well. And when you pull out, gonna be some piece, I mean, gonna be the middle piece as the empty area. Okay. So it will form the watcher. So From what we know here, to find the volume using the watcher technique, which is part of the slicing technique, you have to identify the inner radius and the outer radius. The inner radius is from the axis of revolution to the shortest part of the curve, and the outer radius is from the, the center, which is the axis of revolution, to the furthermost part of the curve. So this is the R out or the outer radius, and this is the R inner radius. Okay. So I'm gonna redraw that figure one more time. So as we see, it's in this form, and this is the axis of revolution. So this is x equals 4. We know it's about y, so we're gonna change everything in terms of y. The y equals square root x. This one, we rewrite x as the function of the y, become x equals y squared. So this one gonna be x equals y squared. And this line is the line x equals 0. So the inner radius is from the axis of revolution to the closest curve. This is the R in or the inner radius. To compute the R in or the inner radius, if you do like in the horizontal way, you're gonna do the right value minus the left value. The right minus the left value, and the right value, which is the axis value or x equals 4. The left is the curve x equals y squared. So this is the expression for the inner radius. And for the outer radius, we're gonna measure from the axis of revolution to the furthermost part of the area of the region. So I'm gonna write here. So the outer radius, the right part would be 4, which is the axis of revolution, minus the left part, which is 0. So R out or the outer radius is just 4. Okay. Next, we're gonna put them all together in one setup of the volume of revolution. So V as the pi integral from C to D. For this case, the y is from 0 to 2. And I'm gonna write the formula again. R out squared minus R in squared, and then multiply by dy. Okay, multiply by dy. From what we set up, the R out or the outer radius is 4. So it's going to be 4 squared, subtracted by the inner radius, which is 4 minus y squared with respect to y. And then what we have to do after this, so this is the setup. After this, we just simplify as much as we can. So this part, we have to perform the square or perfect square of the 4 minus y squared. So we get 16 minus 8 times y to the second, and then plus y to the fourth in the parentheses with minus sign in the front. 4 squared, that's 16. And when you simplify, you will get the integration as pi times integral from 0 to 2. You see 16 and 16 here reduced, but you have to apply the negative side to all terms that's left over after you canceling out. Then we have the integrand in the form of 8y squared minus y to the fourth with respect to y. And then after that, just do the antiderivative using the power rule. Evaluate from y equals 0 to y equals 2. Pi as a coefficient. The first round, put the upper limit value 2 into the y. And the second round, you put the 0, which is very nice because we have the power of the y everywhere. So the second part of the calculation gonna be 0. and the answer will come out as 224 pi divided by 15.